Assalamualaikum. My name is Siti Shafilana bint Yunus and I will do the introductions of Pedestrian Bridge collapse in Florida. The accident was occurred at Florida International University, which is located at Miami. This accident was involved of 5 drivers and 1 employee, which is suffered of fatal injuries. This is happened on 15 March 2018 around 1:45 p.m. A pedestrian bridge that was being built is collapsed. This is because the concrete truss have developed numerous of sides and deep structural cracks. It happened the bridge was currently being built as a single concrete truss measuring about 144 feet and weighed roughly 930 tons. Just 5 days before the collapse, it has been over the piers. There was supposed to be a concrete truss adjacent.
Assalamualaikum warahmatullahi wabarakatuh. My name is Indah Shravin Tazari and I will explain my part, which is the cause of the accident. First of all, I will show you guys the picture of the bridge. The three important parts of the bridge, which is the deck, the 12 truss member and the canopy. So the first cracks that happened was at the truss member number 11 and 12, but I will explain it in detail later. So, after the investigation, OES has stated that the main cause of this accident was the design calculation error that made by the Structural Bridge Design Consultation, FAG Bridge Engineer. For the first structural reason was the shear failure at the junction where the diagonal truss member joined the bottom deck of the bridge at the northern support node. And the second structural design reason was shear lag at the support node, which prevented the post-tensioning cable in the truss's bottom deck from being fully effective and develops to support the tension load demands in the bottom deck. So I will briefly explain the timeline and the few events leading up to the FIU bridge collapse. So the first cracks has developed after the shoring was removed from the under truss structure on 26 February, and on 28 February the photo was taken. The photo of the cracks was taken for the action by the FIGG engineer, and on 7 March FIG has decided that no cause of safety for photo 1 and photo 2, and for photo 3, 4 and 5 FIG has asked MCM to seal the cracks. And the important part is this design was non-redundant, that failure of an individual truss member can cause collapse of the bridge. So next, the truss was transported into its final position and placed on the pier in pilot supports. At this time, no other cracks were evident other than those outlined previously on 7 March. So, VSL then representative of the post-tensioning team to distress the bar in diagonal member 12 and 11. As they began the distraction process, cracks began to appear at multiple locations around the node point where the bottom of member 11 met the bottom deck of the truss, as you can see in the picture. On 13 March 2018, after the discussion among engineers, FIGG asked MCM to put an additional plastic. FIGG also stated that no jacking of the bridge is required because since 10th March, MCM has been monitoring the cracks and they have not occurred inside. So, FIGG also noted that while no safety issues was evident, the restoration works should be undertaken as soon as possible. However, the already evident cracking had appeared to become worse in terms of width and extent. So the next day, on 15 March 2018, FAG analysed the cracks and recommended that MCM place the shim under the bottom deck of the truss as previously instructed by the FIGG. So MCM instructed VSL to proceed with the preparation to retention the PT bars in diagonal member 11. MCM has organised a cranes to be presented on 15 March 2018 to facilitate the works. In the morning of 15 March 2018, two structural engineers from FIGG attended the site to inspect the bridge and the cracks. Next, in the meeting was held with attendees from FIGG, MCN, FDOT and BPA be present. FIGG still stick to their opinion, which is include the crack do not have any safety concerns. Unfortunately, at 1:55 p.m. on the 15th of March 2018, the main truss beam collapsed while the VSL workers were completing the retentioning of members' deliverance. So as you can see in the picture, before the accident and after the accident happened.
Good day to Dr. Shihabuddin. I'm Melissa Lawrence. I'll be presenting on the ethical issues detected at the pedestrian bridge collapse at Miami. First is the poor quality of control by PIG, the engineer of record who failed to recognize that the bridge was in danger of collapsing when it was inspected hours before the collapse. Second is the lack of transparency of Louis Berger work. Louis Berger and FIG did not comply with the intent and meaning of the FDOT provisions of the peer review despite knowing that the bridge had structural deficiency. Third is the conflicts of interest between EOR and CEI. Despite CEI admissions of the cracks growing in size, EOR stated more than once that the cracks did not present any safety concerns. Fourth is the technical incompetence or misrepresentation of competence by BPA. Regardless of the opinion held by the EOR, BPA failed to recognize that the bridge was in danger of collapsing and did not recommend to FIU, MCM, or others to close the street and shore the bridge. Fifth is the mishandling of the sensitive information. Manila Construction Management was aware that the cracks were getting larger as reported by MCM Superintendent and Quality Control personnel in an email, which actually was not the proper way to handle an important information as that. Sixth is the misuse of resources, client and company by the consultant retained by EOR. The consultant retained by EOR to conduct independent peer review of the EOR's design as per FDOT requirements did not check the structural integrity of the bridge under different construction stages. Lastly is the failure to protect public health, safety or welfare by faith despite knowing the risk of the bridge. Thank you.
The next point is code of conduct. Before that, I would like to introduce myself. My name is Vanessa Cela Anayong and my metric number is 201110840. From the code of conduct, it must be related to the ethic from our cases. This is because it clarifies from organization need a mission, principle, and values that linking them to a professional conduct. There are 7 code of conduct that related to the ethics, which is regarding to registration of engineer regulation 1990. The first code of conduct is part IV-24A, which is must work carefully and pay serious attention. And the second one is part IV-27D, write an agreement for the design for both parties to lead a communication well. The third code of conduct is part IV-24B. It should provide safety first to the public and student. Next is part IV-24B. FIC should immediately close SWH Street to protect public from any harm. And the fifth part is part IV-23. BPA should honest and responsibility to FIU, MCM or others to close the street and show the bridge. This is the sixth code of conduct, which is part IV-24A. Registered person should be worked properly and inform EOR immediately if the results are getting large cracks. Last but not least, the code of conduct, which is related to the ethics. The last one is part IV-27A.D. The consultant must be verified and every stage of construction must be in accordance with FDOT regulation.
Hi, Assalamualaikum and good day. My name is Aisha binti Anis. My metric number is 201110736 and I will talk about risk assessment and HARAC. I will combine these two because the format that I use for this is the same, but just for the HARAC I will just add the risk control. Okay, for the risk assessment, first one, the risk level is 20 because the possibility of failing to recognize the danger when inspecting the bridge is high as it can cause injuries, the project to collapse and death. For the second problem, the risk level is 20 because by removing the shoring when the construction is incomplete cause the crack to appear. It is a possible a big catastrophic. Then, next one, the risk level is 5 because the engineer relies too much on the completion program when handling the project. So because they didn't detect the crack in the program, so they neglect the crack in real life and didn't care for others' engineer opinions. For problem 4, when they neglect the crack, the indifference caused the risk level to be 25 because it is the major cause the crack to widen more and thus the bridge collapse. For problem 5 and 6, the risk level is 20 because the possibility of motorized car or engineers or workers being crushed or fall along the bridge is high, it leads to catastrophic, which is injuries, permanent injuries, and death. For problem 7 and 8, the risk level is also 16 because not closing the street around or during the construction will harm the public citizens with injuries, and affecting the surrounding with noise hazard, and heavy loading on the road may cause possible accident around the public. For the last problem, which is problem 9, the risk level is 15 as the design is unsuitable and it is conceivable to lead to catastrophe. As one diagonal fail, the entire bridge will collapse. Okay, so we move on to hierarchy. For hierarchy, we just add the risk control. For the first problem, as the previous risk assessment, we make sure that the engineer and workers has the qualified certification before giving a task in the construction. And they also have to always wear PPE, safe work practice, and daily regular maintenance. For the second problem, the risk control is we have to daily regular maintenance and immediately instructed that the bridge to be short so that it can hold the bridge load until the construction is finished. For the third problem, the risk control is after analyzing or computing the program, always double check at the site and exercise own independent professional judgment to the other parties such as engineers so that we can prevent casualties or problems to arise. For the fourth problem, the involved engineer should know what to do and not just show their jobs to others, and the others engineer must exercise their own independent judgment to prevent the catastrophic from happening. For problem 5 and 6, the risk control is by closing the road path, provide other roads for the public citizen to use, and the workers should always wear PPE and make sure that the workers or engineer has the certificate before giving a task. For problem 7 and 8, they must put warning sign around the construction area, use another road, and close the road near the site. And the engineer must exercise their own judgment to prevent catastrophe from happening to the public. And lastly, the risk control is the engineer should use or choose another design and know which method that is suitable for the bridge that can support the bridge load and overall design. Thank you.
From the overall process of hazard identifications, risk analysis and risk evaluation, it is noticed that the main cause of this accident is ethical negligence. First, minimal effort covering the cracks. This is due to the negligence of the engineer, which was proven to the main cause of this case that lead to the injuries. Second, ignorance of engineers. The ignorance of engineers in performing their duty well, like removing the sharing when the construction is incomplete at the bridge. Lastly, failure in overseeing the environmental risk. Not closing the street or around the construction site during the maintenance, and the concrete truss transport on the street is proven to be failure in overseeing the environmental risk when a construction is ongoing.
To conclude the discussion, one employee and 5 motorists were fatally injured and another employee were permanently disabled. This should be a number that should be taken serious. Members of this profession, engineers are expected to exhibit the highest standards of honesty and integrity. It is clear that engineering has a direct and vital impact on the quality of life for all people. As stated in Registration of Engineers Regulations Act 1990, a registered person shall first hold paramount the safety, health and welfare of the public, 2. Perform services only in areas of their competence, 3. Issue public statements only in an objective and truthful manner, 4. Act for each employer or client as faithful agents or trustees, 5. Avoid deceptive acts, 6. Conduct themselves honorably, responsibly, ethically and lawfully, so as to enhance the honor, reputation, and usefulness of the profession. Therefore, as an engineer, it is our responsibility to provide services that are honest, impartial, fair, and equity, and be dedicated to the protection of public health, safety, and welfare. Thank you.
From analyzing the cracks, the EOR admitted that the calculation could not duplicate the cracks and that it was consequently unsure of their cause. The next is the consultant did not comply with FDOT regulation. That's all from me. Thank you. terjangkau.